welcome to all two of you. Apparently, the world of Davis and Sacramento is having some internet problems, so it wouldn't be terribly surprising to me if there were not a lot of people in class today, which would be fine. Let me go ahead and do the usual things. Attendance. There's the attendance form. Please go fill it out as usual. Let me pin my video here. So as I was saying, Victoria, to the other two people, it might just be a few of us today. Apparently lots of internet service providers are having some issues today. So hopefully that's not the case for everyone for a long time, but it looks like it's just the four of us so far. So let me, oh, there's Destiny. Welcome. So I guess I should put it out there. What kind of questions do you guys have? Sorry, there's something on my keyboard here. There's cat on my keyboard is what there is. What do you want to talk about today? Hey, Himana. Good. Looks like we've got people joining. There's the attendance form again, and so just you type it in case you guys don't have your volume. What should we talk about today? Is there anything specifically you guys would like to see? Hey, Francesca. There's the attendance form again. Someone else came in. Brian's listening. Good. Problems related to probability distribution functions. Sure. Let me think about that for just 1 minute. Text here. For a second. I know what you mean. Oh, I think discrete or continuous. Sorry, I always miss. So I should correct myself there for 1 sec. I misspoke just a minute ago. I said probability distribution function, and the word that I'm actually using is probability density function. Yeah. Let's go ahead and look at that. Okay, so I'm guessing continuous because that's usually the context that comes more in. So, and correct me if I'm wrong here. Yeah, continuous. What I think you're getting at, Kimberly and Himena. Am I saying you're right, Himena? Is it Himena? I'm sorry, my brain not great. If you want to correct me, please feel free. I will try to say everyone's names as correctly as
Himena.
Himena. Okay, great. What I think you guys are asking about is basically using the Z table. Does that sound right?
Yes.
Okay. So again, so we're in the context of Nimdari's class, which is great. And he is giving you guys a Z table. It's also in the back of the book. It's the same one. The one he's posted on Canvas, which I will assume you've all seen it, but just in case you haven't, here is the one that he has shared with you guys. Right, it looks like this. It's a perfectly fine Z table, although it is a Z table that sometimes requires you to do a little bit more work. So I just want to show you, and so there's probably a good Z table on the internet somewhere, and there's lots of pictures here if you look at the images, right? So as you can see, the one he has given us, the one that's in the back of our textbook, only gives the area between 0 and the positive z value that we have. Whereas you can find other ones that give you, like this one, for example, this one gives you all the area to the left of the curve. So if we look at the difference here, right? Here, when I look at a z value of like 0.41, for example, it's got the area under the curve is 0.6591. And that's the area that's under the curve that's left of z equal to 0.41. If we look at the table he's given us, we look at 0.41, the area is 0.1591, which is the area to the left of 0.41, but only to 0. So if you wanted all the area under the curve to the left of z equal to 0.41, you would have to add on the 0.5 that's way over here. So just kind of a point there, you have to kind of make sure you're using the z table that you have in the appropriate way. So if you don't like this one, that's perfectly fine, right? We've got the world at our fingertips. You can use this one here, which is the area to the left of the curve. Now this one, like the one that we have, only shows positive z values. You can also look at this one here, which is kind of small. Let's look at this. Which is super blurry. That's not great. But there are other ones that show the positive and the negative z values, or sometimes just the negative z values. Yeah, some of these are like, okay, sorry, I should have looked ahead of time. Right, I always say that, I know. This one looks all right. Yeah. Anyway, there's also lots of, so okay, here's a great one. Ooh, yeah, I like this one. Great, I'm gonna put this one, I think this one is excellent. The only thing it doesn't have is it doesn't have a picture. So this one definitely goes with this sort of picture, right? Where it's all the area to the left of your z value. So I think you guys could use this one, which is great. Where's the chat? The chat always disappears from me when I share my screen because I forget where it was. Oops. Anyway, so we'll kind of look at both z tables to kind of help us do things. Yeah, for sure, Francesca. So here's that z table that I was just looking at that I think is great. And we'll talk about how that one kind of differs from the one that you guys have in class and how really you can use either one, right? It's not like I don't imagine on your test, you're limited to using the specific z table he has given you. But even if you are, we'll talk about how to do both of them. So there's lots of different types of questions we can ask. And the first ones are really just how to, so not even changing scores into z-scores, but just trying to interpret like how to find the area under the curve. So, or yeah, where's my green pen? Sorry. Let's turn on some lights in here, it's a little bit dark. So a lot of this is going to rely on us looking at the table. So I want to find, so typically we ask questions like, what's the probability that your z-score or your z value is between some numbers or less than some number or bigger than some number? Those are kind of the, right, those are the three kind of things we can ask. What's the probability that z is less than a number? What's the probability that z is bigger than a number? Or what's the probability, actually I can give myself order here. What's the probability that z is between two numbers? Number one, number two. And most of the time for these ones, we don't care if it's a bigger than or a bigger than or equal to, because when you're talking about continuous random variables, the probability that you're equal to one specific value is essentially 0. So we don't really distinguish between less than or less than or equal to. For discrete, it does matter, and we'll talk about that if we need to, but for continuous, it doesn't. So all of these are really just questions about how to read the table. So for example, and we'll do a bunch of each kind, and then we'll kind of move on to how to go from here to the other things. So let's look at the probability z is less than 3. So I want to find what's the probability that z is less than the z-score. I don't know, what have I got here? 1.78. And so this is going to be a lot of screen sharing, I think. Yeah, sure. I think I can do it this way. I'm trying to like not be crouching on the ground all the time. So let's see here. So let's share the screen. Yeah. So looking at the z table, right? If I'm just looking at the probability that z is less than 1.78, I'm going to go. So again, if the z-score is the number I'm looking for the number in the right on the left side and the right side. So I'm looking for the 1.7 and then the 0.08, because really I'm just adding those two together, right? 1.7 plus 0.08 is going to get me to that spot right there, the 0.4625. So here's the thing, right? I'm asking about this. I'm really asking for, right, here's my z-score of 1.78, and I'm asking for all of this area here, which if you look at your z-table here, that's not what they're giving you, right? This z-table is only giving you everything from here to here, right? So looking at the z-table he gave you guys and looking at the value in the z-table for 1.78, God, that 8 is terrible looking. We found a value of, I'm seeing a value of 0.4625. So that's what the red area is here. That's 0.4625. Meaning, that seems wrong. Let me double check that. Oh, that's right. I'm just trying to, no, okay, I think so. So that means the answer to this question then is 0.5, right? All of this area over here, which is always just half, plus that 0.4625, which is 0.9625. Or you could look at the other table, which shows all the area to the left of your z-value. And if we look for the positive 1.78, so if I look down here, let's see, 1.7 go over to 0.08, I get 0.962. So this one goes out to one more decimal place, but if I rounded it to the same, this one is, I would get 0.9624, sorry, 0.9625, right? Because I would round the 46 to a 5. So you can use this table and it just gives you all the area to the left, or you could use that table and you have to add on 0.5 for a positive z-value. Let's look at what happens if we have a negative z-value, because it's even more work then. Also, I did post the solutions to the quiz, so if you have questions about your quiz, go ahead and look at those solutions. So what about the probability that z is less than, I don't know, negative 0.63? So again, well, and so I will say most of these questions especially are going to be easier. Most of these questions are going to be easier if you look at this table that I just sent you guys. But looking at his table, it's even more work. So here's what I know I'm trying to find. I'm over here, there, right there's 0, and I'm over here at negative 0.63. I think drawing these, sorry, let me stop sharing. Can you guys see all right with my screen shared, or would it be better if I stopped sharing my screen? Anybody? Oh, sorry, I don't have the, let me stop sharing, okay. Yeah, sorry, I didn't have the chat available. So, right, if we're trying to find the probability that z is less than negative 0.63, we're trying to find the area to the left here. What I was gonna say is, I think drawing these pictures is always a good idea to help you think about what you're trying to find, right? If I draw this picture, I have a pretty good idea of, oh, I know what I need to do. Now, if I look back at his table for a second, his table doesn't give me this at all, right? If I look at 0.63, so here's what his table is going to give me. If I look at 0.63, right? His table is going to give me this value here. And what I really actually need, well, and so my picture isn't showing it great because I haven't drawn it very well. But what's happening is, let me draw this in red here. I want this, and by symmetry, it should be the same as this. Right? The area to the left of negative 0.63 should be the same as the area to the right of positive 0.63. So, using his table, if I want to find this red area and I'm given this green area, well, these two areas, right, the red, I'm going to write red and green. So the green, which is the value we're about to find, plus the red, which is the value we're trying to find, should equal 0.5. right? The whole right side of the thing is 1/2 of the area. So if I was trying to find the red area using what he's given me, I would say, oh, well, that's going to be, I'm just writing green. The red is going to be 0.5 minus the green. So I look at my table for positive 0.63, and looking at positive 0.63, I see a value of 0.2357, which I can share my screen for just a second if you guys like. I don't know if you guys have the table up or not, so that's why I'm trying to make sure you see it. If I look at 0.63, right, so I go down to 0.6, over to 0.03, and I see 0.2357. So that's 0.2357. And then to find the red area, I just do the subtraction. I say, okay, well, it's going to be 0.5 minus 0.2357, which is going to be 0.2643. So when you have to do something less than a negative number, it's the same as being bigger than the corresponding positive number. In fact, that's probably worth writing. Right? The probability that z is less than negative something is the same as the probability that z is bigger than the corresponding positive something. And that's really just by the symmetry of this distribution, right? I'm going to draw it again. I'm going to try and draw it symmetrical. Here's the middle. If this is negative 0.63 and this is positive 0.63, right, this region here is the same as this region here. And that, at least with this table that he's given you, that's kind of the expectation, is that you use the symmetry of the table to figure out things that aren't explicitly just given. On the other hand, we could have done way less work. We could have just looked at this other table and looked for negative 0.63 and look for negative 0.63. I love that I can like highlight things on this table. Some of the other ones are not so great. So negative 0.63 is right here, and that's a value of 0.264. Probably supposed to round up to 4, 0.2644. We got 0.2643, close enough. Right? They probably both get rounded up, which is why if you add them together, it's not exactly 1, but whatever. So this table, if you're looking for something to the left, super easy. Let me stop sharing. So when you're doing the left of things, if it's positive, just take your table and add on 0.5. If it's negative, you have to take the table he's given you and do this kind of thing. All right, let's look at the kind of opposite of that. So what if instead I want to find the probability that z is greater than 0.46? Okay, well, again, all this is looking at the table. Let's draw a picture. I'm trying to find this area, right, where my z-squared is 0.46. Well, I know from the table he's given us, we're going to be given this area. So whatever area we're given, we know that to find what we want, it's going to be, well, all of this is 0.5, so it's going to be 0.5 minus whatever the blue area that the table actually gives us is. So looking at the table for a value of 0.46, let's see, sorry, looking at his table for a value of 0.46, I see at 0.46, I'm getting 0.1772. So again, right, that area right there, that's 0.1772. So subtracting those, the actual area I'm getting is going to be 0.5 minus, that's going to be 0.3228. On the other hand, we can also look at the more complete table, and we could either, so there's a couple ways you could do this using the, so what I'm trying to kind of point out is there's really a lot of ways to tackle these questions depending on what table you've got. So, whoops, that's not what I meant to do. Sorry, okay, there we go, sorry. Sharing the screen again. We should just share without having to click on it or something. So again, looking at his table, right, looking at the value of 0.46, I just want to verify you guys that, oh yeah, 0.46 is 0.1772. And if we look at this other table here, so I can either look at 0.46, which is right here. And I'm going to cut it off. I'm going to say that's 0.6772. Right. So this other table is telling me that I look at 0.46. All of this area here is 0.6772. No surprise, since, right, it's no surprise that this is that, since it's just the same as this plus 0.5. And then we could find this by doing 1 minus that. So that area would be 1 minus 0.6772, which should be the same, 0.3228. But if we wanted to be even kind of, I don't want to say lazy, if we want to be more efficient about it, we could even instead say, well, I've got this table that's got all these numbers on it. Instead of looking for, right, positive 0.46 and finding the area to the right, I could look at negative 0.46 and find the area to the left, and that would actually be the same. So if I look up back at my table, negative 0.46, which is negative 0.46 right there. I look at that. That's exactly 0.3228 if we round. And that's exactly the value we found there. So right, finding this region here is the same as finding, sorry, it's a 6. It's the same as finding this area right there. So if you're smart about things, you can use the tables to your advantage to kind of do less work, as long as you think about it correctly. Okay, let's do a negative one as well. So what I really want to stress over and over and over again is drawing the picture of what you're trying to find, I think, is pretty key to getting the right answer. So let's say I want to find the probability that z is, I was doing a greater one, greater than negative, I don't know, 1.26. Okay, let's draw a picture. I'm trying to find all this area here. Okay, there's at least 2 ways you could do it. One way you could do it would be to say, well, this is the same as if I look at the area that's less than z being positive 1.26. And so the way I would do that using his table is I would look up z being positive 1.26, which will give me whatever this region is here. So the red will be the number we actually look up from the table, plus this over here, which is just 0.5. So that's one way we can do it. We can look up darn it, red pen all over my thumb. Terrible. We look up positive 1.26. If I look at the table real quick, actually I've got the table literally in front of me. Why do I have to keep it in my computer? Look at the z table here at 1.26. I'm getting the value of 0.3962. So that's 0.3962 plus 0.5, which is 0.8962. Or you could look up positive 1.26 in the other table. And if I look up positive 1.26 in the other table, I should get the same answer. Looking at 1.26, I get 0.8962. Yep, 0.8962. Or you could look up the negative value, which would give you this. Sorry, let me stop sharing my screen. You could look up, let me actually look it up first. You could look up negative 1.8962. 0.26, which is right there, which is 1.038. You can say, oh, this region has area point, I literally just said it, 0.1038. So then you can find this area by subtracting that from 1. And 1 minus 0.1038 is exactly 8962. Sorry. So there's lots of ways to kind of attack these things. All right, let's make it a little bit more challenging and actually talk about this in the context of having distribution of some actual random variable instead of just making them z-values. And we'll also do some in-between ones, because the in-between ones are, the in-between ones are good. So let's say we have some normally distributed continuous random variable, and let's just make up some numbers. So let's say the mean for our normally distributed continuous random variable is 70, and the standard deviation is, I don't know, let's not make it, let's make it 5 so the numbers are kind of nice-ish. Sure, that seems not completely awful. So, and the values can be anything. Most of my values are probably going to be nice integers because that's easier to deal with, but we can talk about them being anything. And maybe I'm thinking about heights in inches, right? 70 inches high is kind of tall. That's not how tall I am, actually. Not that tall, really, right? 5'10" inches, yeah. Anyway, standard deviation 5, probably large, whatever. So let me ask you, with a population mean of 70 and the standard deviation of 5, what's the probability that an individual has a value that's between, I don't know, let's say 88 and, I don't know, 67. Sorry, not Z, X. Right? X is the variable we use, right? So the variable. So what's the probability that someone has a measurement? Let's pretend it's height, since that's what I've already clearly thought of. What's the probability that someone's height is between 88 inches and 67 inches? Well, we have to change this to a z-score. So before we can use the z-table, we have to change this to a z-score, which is really just a way of saying how many standard deviations above the mean is this and below the mean is this. And we can actually look at it. 88's pretty tall. Oh, whatever, it's fine. Well, does the table go that high? The table does not go quite that high. Let's see if the other one does. Sorry, I should look here. Most tables usually go up to 3, or this one goes up to 4. Sure, we can do 88. So we're going to change. So the way I saw this already was I saw that 88 was 18 bigger than 70, and 1 standard deviation is 5, so that's more than 3 standard deviations. Well, let's actually calculate that. So for 88, the z-score is going to be 88 minus 70 divided by 5, which is 18 over 5, which is 3.6. How did I do that so fast? Because I multiplied by 2, which is 36, and then divided by 10. Same as divided by 5. For 67, we're going to get z equal to 67 minus 70 over 5, which is negative 3 over 5, which is negative 0.6. What I'm really asking for is the probability that z is between negative 0.6 and positive 3.6. Okay. Okay, there's a couple different ways we can ask this, which is good. Again, I think drawing a picture is super duper important. Here's negative 0.6, here's positive 3.6, way to hang out there. So we're looking for this area and this area, which you can totally draw as one area, but it might be more helpful using his table to think of as 2 areas. Because, in fact, let me draw them in different colors. Sorry. So this area in red to the right of the middle 0 is actually just given by, well, not his table, is given by this other table. So look at this other table. Pick not a great example. Let me change my numbers. Sorry, I should. Let's make this 83, just so that the numbers are not quite as terrible as I made them. 83 minus 70 is 13 over 5, which is 2.6. Okay, so looking at his table, if I look at the value of the z value of 2.60, I'm getting exactly 0.4953. And that is the area in red right there. If I look at the z-score of negative 0.6, well, again, his table doesn't have negative 0.6. If I look at positive 0.6, so positive 0.6 would give me this area. It would give me that there, which is exactly the mirror image of the area I want. Those areas are the same. So I look at positive 0.6, it gives me an area of 0.2257. So this area right there is 0.2257. And then I can add those together and get 0.2257 plus 0.4953. I probably use a calculator to do that because it's easy to make mistakes. We get 0.2257 plus 0.4953. That's going to be 0.721. So about a 72% chance that someone is between 67 inches and 83 inches tall, assuming my numbers are right, which they are, but that's fine. I mean, what my data is right, not my numbers. Let's look at another one where they both end up on the same side of 0. And let's pick more interesting numbers. So again, for a mean of 70 and standard deviation of 5, I want to know the probability that someone is between, let's say, 72.3 inches tall and 80.1 inches tall. Very specific. Okay, again, we're going to find the z-scores. So for 72.3, z is equal to r score minus the mean divided by the standard deviation, which is 2.3 divided by 5, which is 4.6 divided by 10, which is 0.46. Oh, my stomach was rumbling. I'm getting hungry. And for 80.1, the z-score is 80.1 minus 70 over 5, which is exactly 10.1 divided by 5. And again, the way I'm really doing that in my head is I'm just multiplying by 2 and then dividing by 10. So that's 20.2 divided by 10, which is 2.02. I really can't stress enough. I think it's super duper important to draw the picture of what you're trying to find. Sorry, this pen is trash, literal trash. Maybe not. Maybe it's good for writing over other pens later. So here's my middle. And then I'm trying to look at between, what do we got here? 0.46. And let's grab a red one. 2.02. So here's what I'm going to do. I'm going to find the table value for 2.02, which is going to give me all of this area. And I'm going to subtract off the table value for 0.46, which is going to give me all of this area. Right? And that'll leave me with exactly being between those two. So if they're both on the same side, you usually have to subtract them. If they're on opposite sides, using his table, you have to add them. So looking at, so for z equals 2.02, that's going to give me a table value of, let's see, 2.02 gives me 0.4783. I really want to emphasize here, the probability that we have that we're less than 80.1 inches tall is not 47.83%. It's that plus 50%, right? Because it's this area plus all that, but that's not what we're being asked for. We're trying to find the between part, so we don't worry that this isn't really representative of what we're actually thinking But if someone did ask, what's the probability that someone is less than 80.1 inches tall, the answer would be 97.83%, because it'd be all this red area plus all this I haven't colored in over here. And then this one over here for 0.46, looking at the table, 0.46 gives us a table value of 0.1772. I feel like I've used that number before. So then to find the probability that we're actually looking for, we subtract them. So we get 0.4783 minus 0.1772, 1103. So about a 30% chance. So hopefully these examples give you guys some pretty good idea of what to do if you're given values and you're asked to find the area, aka the probability that you're between some values. Before I move forward with kind of the opposite of that, are there questions you want to pose? Or things I'm missing that you would like me to talk about? The one thing I do want to make sure about, is that do make sure you're comfortable reading the table, right? So let me share my screen again just for a second here. So if you're given the z-score, it's really important, like, oh, the z-score, the first decimal, or I should say, any integer value and the first decimal are always given on this, this first column here. Yeah, and then the second decimal is always, my mouse did it, so my mouse was like being stuck. The second decimal is always given over here. So if you're looking for, like 2.73, you have to go down to the 2.7 and then over to the 0.03. So for a z value of 2.73, the area under the curve between 0 and z is 0.4968. So just make sure you're comfortable reading that table. Let's go ahead and kind of do the opposite thing. So the other thing we sometimes ask about is, and I definitely asked questions like this on your last quiz. So we could ask something like, how tall is, the phrasing of these questions is never great for me anyways. Like, how tall would someone have to be taller than 80% of the population? Again, yeah, exactly. That's exactly where we're going. Good question, Francesca. You definitely read my mind. So again, what's really, so what I've written here, I know how to write down, but I think it's good to draw a picture. Sorry, I feel like I look super weirdly dark. Sorry, hopefully you guys can see it okay. But I feel like, yeah, group shadows are good. So I'm trying to find the place where someone is taller than 80% of the population, meaning 80% should be to the left of my score. Right? I want to be somewhere over here where I am taller. My height is bigger than 80% of the population. So if we're using the table Nimdari has given us, we're actually looking for the area part to be 0.3000, right? Because this part over here is the other half. So if we're using Nimdari's table, we're going to look in the z table for 0.3000, and then we're going to find the associated z-score. So when you're given the area, you have to look in the table and then look out to the z-scores to find the score. And it's kind of backwards. Let me share my screen. So I'm looking in the z table for the value that is closest to 0.3000. So let's see, looking here, I see so 2, 2, 9, 2, 9, 2, 9. So I believe, and this is, I'm not exactly 100% sure about this, but I believe you're supposed to pick the one that's just closer. So I would be picking the one that for 0.2995 because that's closer to 0.30000 than 0.3023 is. So I pick 0.2995, 0.2995, which is associated with 0.84. So my Z naught is 0.84. Or if you prefer, we can also look at the other table. I see there's something in the chat. I need to pop out my chat, but I always forget how to do that. All right, there it is. So we should add them and get the average. Okay, that's fair. So that would be basically, so if you're doing between so the average is just going to be one more decimal place with a 0.5 or another 5. So like if I was doing the average of, where'd you go? Sorry, I lost my spot here. I literally wrote it down 0.84. So I would go between the average of 0.84 and 0.85 would be 0.845. Right? If I'm doing the average of 0.84 and 0.85, that would just be 0.845. Or you could also look at the other table, right? And if I'm looking for the area to be 0.8, right? Because the other table gives you all the area to the left. If I look for 0.8, I should be looking in the same spot of 0.84. Right? So right between those two values is where I'm finding 0.8, again, at 0.845. Same thing either way. Yeah. And so then we're not done with the question, right? Because the question wasn't what's the z-score. The question was what's the height. So then you have to take your z-score of 0.845, set it equal to your x minus the mean over the standard deviation, which is, I should say, right, we do this. Your z naught is equal to your x minus your mean over your sigma or your standard deviation. And then you plug in all your known values. Your z naught is 0.845. You're solving for x. Your mean was 70 and your standard deviation was 5. Right, from the previous example. And so then, this is just, right, let me just do this algebra. So 5 times that, this is a good time to use a calculator. 5 times 0.845 is 4.225, and then we add 70. So we have 5 times 0.845 plus 70 equals x, and we end up with 74.225. And then maybe we round to some like 10th or 100th, right? So you might say the person who's taller than 80% population is 74.2 inches or 0.23 inches, whatever decimal we are told to stop at. So that's how you would attack a problem like that. But it is, the thing I want to kind of make clear is you have to make sure that you know if you're trying to find the area to the left of your score or to the right of your score, right? So here the question was, how tall would someone have to be taller than 80% population? But I could also ask the question, so we were trying to find, right, the probability that z less than z naught was equal to 80%. But we could also phrase it in a different way, like and I feel like this one especially, the words are kind of misleading maybe. So I could say, how tall would someone have to be so they were shorter than 60% of the people out there. And you certainly could rephrase it so that you just say, well, if I'm shorter than 60%, I'm taller than 40%. But let's not do that. So I'm trying to find the probability of z less than some z naught. Sorry. Well, let me actually, so again, I can't do this without drawing a picture. So here I am, here's the middle, and here's my Z naught, where I am shorter than 60% of the population. So writing it the way that Francesca wrote it there, I'm trying to find the probability that Z is greater than my Z naught, right? Because I'm looking at the area to the right now, is equal to 0.6. And one way, so there's a lot of ways you could do this. One way you could certainly do it is it's going to be, that's my garbage. It's going to be the same as the probability that Z is less than Z naught is equal to 0.4. Right, that's definitely one way to do it. If it's a greater than, you can just flip it to be a less than, where it's the complement amount of area. But let's pretend like we didn't think of that. Let's say, no, I'm going to do as a greater than. So I'm trying to find the Z-score where this area is 60%. So what I'm really trying to find is the Z-score where this area is 10%. So what I'm actually going to find is I'm going to look at the Z table. I'm going to find the positive Z value that goes with having 10% right there, or 0.10. And then whatever that positive Z value is, I'm going to use the negative of that to figure out the Z value there. That's what I would actually do using his table. So looking at his table, what have I got here? Looking at his table, where did he go? Sorry. So looking at his table, I'm looking in the table for 0.1000. And let's see, it looks like it's between 0.25 and 0.26. So I would say 0.255. So this value is 0.255. Okay, I'm gonna stop sharing. So then what I would do is, well, okay, well, if that value is 0.255, then this Z value here is negative 0.255. And so that's the value that I need to be bigger than to get 60% of the area over here. So then I know that my Z naught being negative 0.255, that's going to give me 0.6. So that's the answer to the first part of the question, right? Okay, I found the Z value. If my Z value, and it should be bigger than the negative value, right? If I'm capturing more than half the area, I should be bigger than some negative Z-score to get more than half the area. Right? If I was bigger than the positive Z-score, I'd get less than half the area. So that's also something worth thinking about, right? If you have more than a half or less than a half, it should help you kind of figure out which side of the mean you should be on, if you're bigger than or less than. Now I'm just going to change this Z-score of negative 0.255 into an actual height. So again, and so here's some context, right? A Z-score of negative 0.255 is about a quarter. So that means I should be 1/4 of a standard deviation below the mean, about. So since my mean was 70 and my standard deviation was 5, I'm expecting to be about 1/4 of 5 less than 70. So somewhere around 68.75. Let's actually do the math. So my Z-score of negative 0.255 is equal to X minus my mean divided by my standard deviation. I multiply. And then I add 70. So 70 plus this number here, 5 times negative 0.255, equals my actual height, which is going to be, let's see, 5 times negative 0.255 is negative 1.275. And if I add 70, I get 68.725. So that's how tall someone would be that's how tall someone would have to be shorter than 60% of the population, or phrased alternatively, taller than 40% of the population. So when they're saying that the probability is equal to a number, you have to look inside the table. And so I know we're just about over here, but let me go back to this sharing screen. Right? So if they're saying the probability is less than the number, like those last two questions, you have to look inside the table for that number and then find the corresponding z value on the outside. On the other hand, if they're telling you the probability that z is less than some number or greater than some number, you have to look for the z value and then find the corresponding probability. All right. Oh, let me give you guys, let me just give you the, that's not what I want to give you. 1 second, one thing. Where'd you go? Oh, my screen is being annoying. Sorry. Let me just give you guys the attendance one more time. Do make sure you fill that out. But that is all I've got for today. So hopefully that was helpful. You guys asked some good questions, and I think we did a pretty good job talking about this. So that said, if you have other questions about this, don't hesitate to send me an email and ask me, and I can make a video or start a discussion in Canvas, and I can comment, and your classmates can also comment. We can kind of do more if you need to or want to. All right, that's all I got. I'm going to end it. You're welcome, of course.